Garth Eaglesfield is a systems architect. And Garth, let me ask you a question. How does Digitask help companies who are involved in the arena of e-commerce?
Well, some of the features that e-commerce is bringing out in business applications intimately bound up with systems integration and high-performance systems. If you think about it, if you take something like a stock trading system, 5 or 6 years ago, a stock trading system would only be used by perhaps a few hundred professional stock traders. In today's economy, that same application is probably used by millions of normal, untrained consumers sitting at their web browsers. So in order to make the modern stock trading application work, it's critical that it's up and running 24 hours a day, 7 days a week, which means that it must be able to handle huge transaction volume rates. All of this needs to rest on some kind of high-performant, highly available infrastructure, and that's where Digitask can come in to provide that infrastructure. In addition, there's a whole host of system integration issues. Let's take again the stock trading example. When a consumer is doing a stock trade, they expect that to be executed in essentially real time, and this can have all kinds of implications for more traditional business applications, the so-called back office systems. So these need to be integrated with the front office systems, the trading applications. You can envisage it almost like needing to put in a lot of glue to stick all these things together. This is sometimes called middleware or application server technology. So there's a whole range of issues that are brought on by e-commerce, by web-style applications that Digitask can help with, and they do really all fall under that general heading of high-performance integrated systems.
These terms you use, middleware and application server, what do they mean?
Well, I guess, again, if we take an analogy, a lot of people feel comfortable with ideas about data and databases, and other speakers in this show have spoken about them. But, of course, if you like, the lifeblood of a modern corporation is the business processes that it's executing, and these are executed by actual software applications. In a web-based application, that software can be distributed across many different machines, in many different geographical locations, and so some kind of software known as an application server technology, or perhaps as middleware, needs to be present on all those machines in order to make this widely distributed application work. Say, if you consider a stock trade, there's a phrase we hear a lot nowadays, straight-through processing, which means the ability to link the stock trading application, the back-office systems, the risk management systems, all the different systems together to execute seamlessly a single trade. Those systems are quite likely all on different, one may be on a mainframe, one on a server, one in New York, one in California. Bringing all that together requires middleware or application server style software to make sure the different pieces of the application can work together.
Does this apply to all kinds of companies and businesses, or does it really relate just to one specific kind of industry?
I think the same challenges face all market sectors nowadays. I've mentioned the finance sector, where straight-through processing is kind of the buzzword of the moment, which implies that all the different stages of a trade can be linked together in an automated fashion. If you look at telecommunications, there's issues like self-service provisioning, where the idea is that a customer to a major telco should be able to provision their own network. Again, this has major integration implications for the applications within a telecommunications company. With manufacturing and retail, we hear about e-procurement, about supply chain automation. It's the same kind of issues that all those applications that in the past may have been separate, so-called stovepipe applications, now need to be integrated together and exposed over the internet to either consumers in so-called B2C systems, or indeed to other businesses in so-called B2B configurations.
The interesting story of a company called Digitask, where understanding technology makes the difference.
That was a look at the operation of a company that we singled out as being instrumental to the heartbeat of this city.
There's been so much interest in this business since we first aired that profile that we wanted to give you an even closer look at what it brings to the global marketplace.
Paul Baumgartel is a principal consultant for Digitask, and Paul, explain to me something. How would a company ensure that the data that they have is always available, and also ensure against damage to the disks?
We can't ensure, to answer the second part of the question first, we can't ensure against damage to disks per se, because disks are very complex and, let's not forget, mechanical devices. Everything else in your computer system is electronic. The only thing that moves within them are electrons, electrical impulses. With a disk, you actually have platters spinning at a very high rate of speed, and what are called disk heads that pick up or lay the data down on those platters. So the possibility of mechanical failure is always present. What we do to ensure that data is always available and always possessing integrity is to provide redundancy, once again, and this is a word you hear a lot in computing systems. If we cannot guarantee against a particular piece of equipment failing, what we do is provide 2 or 3 copies of that piece of equipment, so that if one fails, we still have the other. Statistically, you get to a point where the possibility of having all of your copies fail is so small as to be almost infinitesimal. So what we can do is a number of things. First of all, we can, on a local single computer system, we can do what's called mirroring the disks, which means each disk drive has an exact copy, a separate disk, that in fact stores the same information. When I write to the disk, I'm actually writing to 2 disks.
You're doing an immediate backup? Is it the same?
It's not the same as an immediate backup. It really means that we always have 2 copies, and that it's as though our write goes off into 2 channels, and we've got both disks picking up the same data. So again, if one physical disk fails, we've got the other one. That's very commonly done today, disk mirroring, and you find that in many, many systems. And there are then many variations on disk mirroring that get into technical areas that I won't go into right now, but suffice it to say that it's the foundation of most of those kinds of technologies. The other level, or the next level, is to do what's called a standby database, where rather than having, this would protect, the disk mirroring would protect against a failure of a particular disk drive, let's say. But what happens if a fire breaks out in your computer room? Having 2 copies of the disk doesn't help you there, because they're both going to be damaged. So you can get to something called a standby database, where in a separate physical location, we have another computer system with its own disk drives. And as we make changes to our data on the primary, we send what amounts to a log of those changes, or a journal of those changes, over to the second machine, the standby, and those changes are applied. So it's as though we have a remote copy, and everything we do here, we duplicate over there. It's done at a somewhat higher level than at the level of the disk itself. But the advantage is that it protects against disaster in your primary location.